يكونوا معاك موجودين في تونس. وأما بالنسبة للسبيتش بتاعي اليوم نخير نعمل باللغة الإنجليزية إذا كان يساعدكم، وإذا كان فما أي سؤال وأي حاجة باللغة العربية ولا باللغة الفرنسية مش مشكلة. Alright, so I'm going to switch to English and talk a bit about AI revolutionizing search and education. People talk about AI, but really in the recent years we talk about LLMs. It's about large language models. AI has been there for a while, from the 60s, and it has ups and downs, as we heard from people here in the community, and that's correct. But really what is happening right now is mostly LLMs. Okay, try again. Okay, let me go to the next slide. So, how do we arrive at here? We went from what we talked about language model to large language model. So, personally, after spending 6 years in NC, Commercial Software Informatique, I went to India, Nancy, and my PhD was in large language vocabulary for speech recognition. So I started with a language model around 1995. Well, but then language model is really different from what we're talking about today. I mean, I have vocabulary for 20,000 words. And for me, that's 10x, 100x from 2,000 words that was happening at the time. Today we talk about billions of words. But I'm not saying that I started language model because there's a lot of people behind me and before we started language model, and that goes to, so before that, I'll skip this slide, I'll get back to that. So please, like to mention what is a language model, maybe that's important for people that are not aware of what is happening. I'm here giving Google image, I'm sorry. And then you start to set the level of words, here like how is the weather, and you ask the model to say what is the next word, what is coming next. And here, in the first case, how is the weather, it will show you maybe the name of the city, and the other case, when you say how tall it is, it will give you the most likely searched word, and in this case is Taylor Swift. So again, the idea of language model is not really new, that's my point, and what it means, the language model is predict what's coming next, given the context. And this is what my point, what I'm saying. Actually, people start talking about language model in 1913. Here, we have Roger Markov. When he was reading the book Eugene in English, he would figure out that letters don't appear randomly in a text. Letters have a sequence. They have a likelihood. They have a probability. He didn't put a theoretical formula about it, but at least he got into the spirit of things are not happening randomly, even when you are writing a book, even when you are writing the letter. And we waited for a while. We waited until 1951 that Louis Shannon published the first paper of the prediction of the English letter. He kind of put the foundation how to predict letters in an English text. And it was, I would say, one of the first mathematical formula for the language model. And we still have today what we call the sham game. And the sham game is just, it gives a set of letters with characters or word, and they tell you what is coming next. Then, Jelinek and Mercer at IBM in 1985, they took that to the next level and they said, okay, the probability of a sentence is the probability of different words on it, and probability of a word is given its history. And again, now in 51 start to talk about probability distribution, we start to talk about how to assign probability to sequences, and now we move away completely from talking about linguistics, talking about theory, and now we are at the space of talking about statistics and talking about math. So I had really a chance to meet Jelinek in person when I was at IBM. And one of the things that always he was mentioning is that when I reduce the number of languages in one department, the performance of my speech recognition system increases. So it was a contradictory a little bit, but his point was saying that there is a lot of room on using statistics, math, versus linguistics when it comes to speech recognition, machine translation, language modeling, and so on and so forth. So I really believe the combination of both is required, but at that time, it was a big rise toward linguistics, and he was one of the first to move a little bit the community to the other side, the side of probabilities. So even in the lab work, we still have work. I remember this was in 2002. We did some work with Oriental. It was a big collection of Arabic data going from, North Africa, Egypt, Middle East, and we went through until Turkey, where we were able, but it was an European project. It was one of the first initiatives to build speech recognition and language model for Arabic. So kind of also the work on Arabic happens before as well. There is some work in Egypt, in Sahara and all of that. But I think the one that I would say that was more at international level, it was in 2002. And then we went until 2000. And then suddenly in 2000, what had happened is Benjio, who is from the University of Montreal, he said, okay, this language model, people use conditional probability to really people work given the context. And he said, oh, can do that with neural network. So he was the first one to use neural network that at that time it was not famous as a technology. And he said, I will apply it to language, to words. And then attention is all unique. We waited until 2017, and Google published its first paper on attentions, and that kind of, let's say, the starting point, the birth of LLMs or generative models. So this was supposed to be animated, but unfortunately I don't have the information, so good information, so I'm showing this way. But what I want to show in that slide is that there is the input that gets consumed to generate the following output, and that keeps going. So also something to notice is there is really no intelligence. It is mostly consuming a bunch amount of data and figuring out what comes next. Here we don't talk about work, we talk about token. Why token? Because a token could be a word, it could be a pixel, it could be a frame. So if it's a pixel or set of pixels, we are talking about images. When it's a frame, we talk about video, and when it's content, we talk about text. And it doesn't have to be a word, it could be a mark, it could be anything. So, and as the models are getting bigger and bigger and bigger, the same models are able to learn and consume different types of tokens, and that's what we'll try to talk about it a bit later. Now, people sometimes say, oh, we may reach out AGA, they're going to replace human. All of that are open questions. The reason why they are open questions, I don't think the current technology will allow us to do that. But we are in a good path to generalize over time, and also I think we need to agree what is the definition of consciousness and what is the definition of AGA. Because the model can do a lot of things, it doesn't mean they are conscious if we agree on the definition of conscious. Why am I mentioning this? Because the number of there is a constant number of computation steps that happens on these models. And also when it comes to reasoning and planning, we are really still in the early stages. There is a lot of progress. I will talk a little bit about that later. But the road is really still a few years to go, I think, to achieve a good level of planning and factuality. And then we talked about history and what it happened. We have this since 2017. People are working on all of this. Why we waited for 2022 to start talking about OpenAI, Gemini, ChatGPT, and all of that. Actually, many things. start with the computing. When we start working with the transformer, all of these models, they work with the 100 billion of parameters, and suddenly now we talk about billions of parameters. Some of the models, they have 500 to 600 billions, getting to a trillion. Huge, huge, big, very big. That means a lot of power. To train a model, you need the electricity that, maybe all of Asia, just to train a model. That's why recently there is a lot of investment in power. There is a few deals that have been made, many companies, Amazon, Google, and all of that to buy nuclear, to have a deal, not to buy, to a nuclear plant, so that they can have access to electricity, which is really important for those models. So that's one criteria. The following criteria is quite broad. We have a lot of data that we don't have before. Now we talk about billions of tokens available on the map, and if it's not available, you can access it through different type of sources. So I'll show here another example. So here I'm showing the training flops. Let's say we have that as the computation, and then the accuracy. So in the beginning, if I take the arithmetic part the most to the left, okay, and we have the same model. We are training the model with 10 to the power of 18, 10 to the power of 20, 10 to the power of 22 parameters, and nothing is happening. We didn't change the data, we did nothing. We just kept increasing the number of parameters, and suddenly you start seeing the movement in terms of accuracy. So somehow the model starts to generalize and start to have the sense of smartness, even though it's more about computation and more. And I mentioned that on the case of arithmetics, but the same thing for transliteration, the same thing for multitask, multi-language understanding, and so on and so forth. Now, what is really different, in the following, I will focus on two parts. Part of it, how Gemini or LLMs are influencing search, and the other part is how they are influencing education. So when it comes to search, I think there is paradigm shift that is very, very important that I'm observing. Let's say as of 2-3 years ago, usually people issue a query. We try to figure out a document that is closest to the query, and we show that document. And then the whole work is how to make sure that we consider synonyms, the proper words out of the query, we try to understand the meaning, what are the keywords. So the focus really in keywords and fetching a good match for the documents and showing those documents. That completely shifted with the LLMs. Now we want the LLM to do the search for you versus you doing the search by yourself. What does that mean? You issue a query, you make the assumption that you don't necessarily know what you are searching and would like to help you. So, for that, there is many angles to look at it, and that's what I try to share with you next. There is a part that is easy, which is, let's say, I show to you directly the answer through summarization, or go to a document and show the content. Also, now, if you have an Android phone, Samsung or Pixel, you can do your search, a combination of pictures as well as the text. So the search by itself becomes multimodal. You can take a picture and you say, well, this happened. Or you can take an object and you say, I would like to buy this one. And to respect the color, so that's what we call, or the form and all of that. And that's what we call multimodality aspect. The simplicity, the plans, customization, organization, these are the 4 parts that I'd like to deep dive a little bit on them in the following slides. Okay. So I Again, it's unfortunate that one is not moving, but that's fine. So we came with the idea of a chain of thoughts recently in the last 2 years. And what is this idea of chain of thoughts? So you have a query, we try to generate a plan out of it. So if my query is, I would like to travel to Tunis, I have a budget of 1,000 dinar, and I have 3 days to spend. Show me a plan. This is not about showing you a document that is doing that. This is about taking the query, generate a plan. The plan will be, as an example, it's all done by the machine, all done by the LLM. The plan will be, what's the interest of this person? There is the personalization aspect. There is another aspect which this person is traveling on a project. There is a third aspect, how we need to collect the information related to different prices and events happening right there. So all of this information are collected, are summarized through a plan. A plan can make a call to be modeled again to refine it and then provide the results. So that's why if you are recently using Gemini or using ChatGPT, you feel that they are slow. They are slow because we said they are reasoning, and really what it means reasoning is they are generating the plans and the plan generating another plan and they're trying to summarize all of that to show the results. So research could lead to 10 consecutive research behind the scene, but at least you get the result you want. We give you also another example that is interesting and fascinating that I found. Here I show a query, a train traveled at 60 miles per hour for 2 hours. How far did it travel? Show the steps, answer in Arabic. I have it working on my laptop. If there is an opportunity and people are interested, I can show demos later on. But this is really real now. So you take such a query and you ask to define a plan. And here it's showing you the plan what it did. So it's telling you that المسافة والسرعة والزمن. She's saying المسافة هي السرعة times الزمن. Also replacing the السرعة, replacing the zaman, it find the distance, 120 miles, and then providing the answer. So it's really doing it one step at a time. And by the way, I issued my query in English. The answer is in Arabic because I asked them to translate it in Arabic. And they can ask any other languages that you want. And this is a really simple query, but there is more query that are more complicated than that. This is an example I showed. I did it offline, but happy to do it online if we have a good connection later. Which is, this is the example I mentioned. أريد خطة رحلة 5 أيام إلى تونس مع تفاصيل معي 2000 دينار تونسي. And as you see, it's generating day by day. It's telling me day one, you arrive in Tunis, you take taxi, you go to your hotel, in the evening that's what you do, that's what you do the second day, in the morning, in the evening, in the afternoon. And they can follow the discussion. I can say, oh, by the way, I have 2 kids, and they are less than 13 years old. So can you provide special activity for those? And then it will change that. This is an example. Another example was for those interested in food like myself. And when you said, okay, give me a plan for 4 days, what I can cook every day, and this is my budget, and this is the food that I'm interested in. I would invite vegetarian, or I would like to eat only fish, or something like that, based on your interest. And all of that is possible right now. Why it is possible? This idea of taking a query, doing planning, decompose it on steps, execute every step, and then do it again. It's a new thing that we don't have before and we can do with the era of LLMs. This is the example I want to mention about food and what you can cook in daily basis and provide recipes, and you can change recipes on the fly. And all of that now is done. So also I remember when I started working on this area, we write a lot of code and we compile and it's getting complicated, where now it's done through prompting. So in terms of education and in terms of possibilities that open, I assume and I think that most of people could write applications, and this will change the spirit, how we see things. This is something that it is harder before. You need to learn specific language, you need to be proficient in either C++ or Java or Python. Now prompting is much easier. You keep prompting with a model, and you do maybe a few tools to do some reinforcement learning, and applications are there. Another area that I'll spend a bit of time on it, and it is about education. I'll share a link later for those interested, and also happy to show you. A couple of months ago, we released Gemini. We released an offer that we call Study Smarter with Gemini, or a career quality smarter. And the idea, how to use the large language model to help in education. How to help students, mostly, learn new materials or quickly at their pace. And what offered actually, it offered 5 types of ways to interact with the model. One of them, what we call personalized learning. People are different, learn on their pace. They don't consume the information the same way. And we observe that the LLM help to address your specific need. There's people that prefer to learn through schools, question, answer, ask question, get the wrong answer, try again, have a correction. There is other they would like summaries, they would like keynotes. There is different ways of learning. There is no one way of learning. LLM help you do that. And that also makes it individual personalized. Another way is enhancing content creation and access. So when we talk about education, we know that LLM hallucinates. So we don't want to trust the generic LLM. But we have the capability to ask the LLM to focus on the documents we feed it to them. Many of you know the technology flag, something like that, where you can select a set of documents, content, so Wikipedia, feed that into the model, and tell the model, I want you only to focus on the content in these documents, don't hallucinate, or go somewhere else. I want you to focus on those. If those documents are of interest, then it's a good way for learning, because you know that the information is coming from those documents, and it shows you reference. It tells you, if you want an answer, it tells you this place in the document I found the answer. You can go and look it by yourself. So time is, I would say, 1,000 bytes, or better to before. It also a power indicator, in the sense that what we observe is that sometimes it's easier to assess, to let the machine help you assess what the student did, and then on top of that you can focus on areas of improvement versus spending a lot of time on things that could be simple for assessment. And as well, it helps you have the way to evaluate students' data level. You get statistics over time, you know the area where there is strength and weakness. It points to different specific materials and area where the student could do better. All of these are things that are done by the machine, where it takes a lot of time to do it before. The other two, critical thinking, what we observe that the way we interact, sometimes it helps. And in a classroom, having also help from a machine on what are the area of focus is of benefit. And the lifelong learning, as you have a personal assistant in a certain way, you can learn on your pace and take the time to need. So there is a challenges. Not all loans are, I'm not saying everything is good. We still have the challenges that we also have work to do. There is ethical consideration. The way I see it is LLMs reflect certain type of culture, because saying it from the data that is available that speaks about the culture, The data on the internet has one point of view. It's not about correct or not correct. It has one point of view because most of the data are there. When the data is factual, doesn't matter. Some of the data are cultural, and for those cultural data, diversity matters. Today, most of the data that are on the internet reflect some part of worldwide cultures. Accordingly, there is also work to the community here to think how we can influence large language model with the local culture. Then there is also a problem of equity. Not everyone has access to those models. As I mentioned, they are very expensive. They cost a lot of power. The future will be bright. I'm sure that computation costs will go down. But it's going to take time, and accordingly how we can address that quickly. And also balancing technology and human interaction. This is always an interesting phenomenon. Should you have more human or should you have more machines? Is machines better than human? Are human better than machines? It's a debate, but it's important to think of this. I mean, at least where LLMs are used today, writing the code is becoming very easy. Most of the LLM increase productivity by close to 80%. This is also an example where, again, it's supposed to be animated, but you show a picture and you ask the question was, how many, here we have muffins, and the query is how many muffins each kid can have, and just by looking to the picture, generating a plan, you can get your answer. One thing was interesting, what we observed at least on several studies, machines provide more empathy than human doctors. So what was observed in the US, that doctors usually are blunt when sharing knowledge and telling what is happening, where the model tried to present that in smooth way. And most of the people that interacted with the machine to provide diagnostics, they were happier than interacting with you. Also there's concerns about, as an example, correlation. They did also a study in the US, and they found out that the machine is more convincing than you, and accordingly it can smear the vote toward one direction or another. That's something to consider. And also another problem is that we would like to train on trusted data. Today there is a lot of content in the web, a lot of content that are related by machine. And accordingly it is tricky because we want to learn from good data for the model to improve, but if we content generated by the machine and that machine you don't know how the content is, how you can do that. So there is also a lot of work how to figure out who are the correct content from non-correct content. And my last slide, looking to the future of large language model. There is a lot of opportunity to revolutionize work. There is repetitive work, could be replaced by machines, saving time, also cost. Enhancing creativity, there is a really big way on increasing creativity. Personalized experiences, democratize knowledge, that's what we aspire for. At the same time, it is important again to reconsider the ethical consideration. All right, and thank you everyone.
شكرا جزيلا للمهندس عماد زيتوني على هذه المحاضرة القيمة والرائعة. نستطيع أن نأخذ سؤال أو اثنين، نعرف أننا تجاوزنا بكثير الوقت، ولكن حضور سعادة المهندس عماد زيتون يمكن أن يعني نتجاوز بعض شيئا ما نتجاوز بعض الوقت نظرا للقيمة العلمية لهذه الكفاءة العربية التونسية التي نفتخر بها. الأستاذ الدكتور علي فهمي، تفضل.
شكرا جزيلا دكتور عماد. I enjoyed the talk. I have two questions. السؤال الأولاني حول ال emerging capabilities اللي بتحصل لما يبقى اللارج لانجوج موديل السايز بتاع البارامترز بيكبر والداتا اللي احنا بنعلمه بيها. ليه الظاهرة دي بتحصل؟ ليه emerging capabilities؟ السؤال الثاني في البرومبتنج انجينيرنج حاليا في جديرا يعني layer of thoughts. ايه الفرق بينها وبين chain of thoughts اللي حضرتك اتكلمت عنها؟ شكرا.
For the first question, the question was about why the increase of computation and data led to where we are today with LLMs. The way I see it is, as we have a vector representation and dense representation before, as the number of parameters are smaller, the information sometimes got ignored, and it's hard to generalize. With increasing the number of parameters, there is a possibility that part of the network will focus on one part, while the other will focus on the other part. The MOE technology as an example, where sometimes the area of the network will focus on, let's say, images, the other on videos, the other on text. Even though it's still this one network, and the learning is done automatically, not by human, so the machine knows where to focus. That's one interpretation I have. On the other questions, which is about, sorry, can you repeat again? That is the topic.
Layer of thoughts versus chain of thoughts.
Yeah. So the problem actually is really a language where when you interact with machine with text, and the machine provide an answer, and the answer could be a summary. The chain of thoughts, it is really the planning. So your thoughts can generate a plan. The plan could generate also other thoughts, and you keep doing looping until you converge to a place where the model is sure, confident to provide an answer. So in the chain of thoughts, there is a repeated loop where the machine is also doing prompts. So in the chain of thoughts, human doing prompts, machine doing prompts to get the results. On the prompting only, it's one shot, it's one iteration.
شكرا جزيلا. سعادة الأستاذ الدكتور علي فهمي هو سيتحدث اليوم بعد الظهر، وهو عميد كلية الذكاء الاصطناعي في جمهورية مصر العربية. الأستاذ الدكتور أنيس حوض.
شكرا على المحاضرة القيمة. معكم الدكتور أنيس حوض. عندي سؤال فيما يتعلق بالسكيلينج of large language models. Now you mentioned that we've tried several scales in order to reach some kind of accuracy in the reasoning. I'm wondering whether small language model could be a viable opportunity when we don't need to have all these kind of information into one language. Now current languages, they do deal with multiple languages of people, Arabic, English. If we think about an Arabic language at smaller scale with clean data, do you think that we can reach some good accuracy at something lower than 7 billion parameters, or it's kind of difficult? Because now there are some studies that says the scale doesn't matter, it's quality of data. Some other day mentions that the scale matters more than the data. So what do you think about this controversial topic?
No, plus one, I agree on that. It depends on the application. So there is many models now that they can run on the phone. They are 1 billion parameters and they do very well, but the application is very specific. For those big models usually are used as a teacher to help train smaller models, because in production, when you are at scale, you cannot afford to run those models, otherwise you need the electricity of half of the world. So accordingly, none of the model is very large, that is deployed in production, but the large model has the value to be the teacher to help train the smaller model catch up. So 7 billion is good, but how that 7 billion is trained, that's the good question. So if you have maybe 400 billion parameters model helping that 7 billion catch up in terms of performance, that would be fantastic.
Thank you. So like models like Gina or OpenAI, they work like at the biggest model, or it's like a team of experts at smaller scale, because now Yeah.
It is both technology that are available right now. So the team of experts is mostly focused on when you have specific application in mind. If you'd like to do summarization according to survey, you don't need a very large model, and those can happen. Large language models today are doing for two purposes, as I mentioned earlier, the teacher part, and the second part is to see the capability of reasoning that you don't see with the smaller ones. So what you do is like, you play with the big model, you understand what you can do, and then once you know what you can do, then you go to the smaller model and try to make them behave that way.
شكرا جزيلا. سنأخذ سؤالين اثنين. سأخذ سعادة الدكتور زهير خليف من جامعة النجاح الوطنية بفلسطين الحبيبة، والأستاذ الدكتور بيرك كمون، والدكتور كثير خريجي من تونس ولا من قطر؟ دكتور زهير تفضل.
السلام عليكم. يعطيك العافية يا دكتور أمير، كل الشكر والتقدير لك على محاضرتك، محاضرة قيمة جدا. في الواقع عندي استفسار بخصوص توليد الصور باللغة الإنجليزية. غالبا لما نكون بكتابة الأوامر التوجيهية، حتى سلسلة الأوامر التوجيهية تكون الكتابة على الصور غير واضحة باللغة الإنجليزية، يعني حتى نخربط، حتى نحاول نعدل، حتى لو قلنا بعملية إدخال الصور موجودة ولكن تبقى المشكلة قائمة، ونفس المشكلة موجودة حتى بالكتابة باللغة العربية.
صح.
اوكي، ناخذ 3 أسئلة. مهندس عماد عندما تجيب مرة واحدة. تفضل أستاذ الدكتور بيرك كمون، تفضل.
First of all, I'm very proud of you. Former student of my school, MC.
Yes.
I very much enjoyed your talk. I have 2 questions. The first one is I'm curious to see if you have an explanation of those curves. You know, this is more for professor side. You said the curve at one point they really jumped. Do you have any kind of explanation? My second question is, I am faced with this following. I have a school that I have to run. I want to introduce AI and to get really the advantage of all the features you share. How should you do that? What would be the roadmap or the methodology or the approach that you can advise us to? Thank you.
شكرا. دكتور كثير خريجي، مركز مدى للتكنولوجيا المساعدة دولة قطر. هو موظف سابق، يعني الدكتور كان خبير في الأليكس.
Thank you, Doctor. Thanks a lot for the amazing presentation. Actually, I got one question regarding the sector where I'm working, which is digital accessibility. You mentioned, I think, a couple of times in your presentation, digital accessibility. Once when you talked about leveraging generative AI in education, you mentioned that using generative AI should be understandable and accessible for all. So there is a need to enhance accessibility. And as a challenge, you mentioned also that it's a big challenge how to make generative AI and AI in general accessible for all. So my question is about this side of generative AI, and especially for Gemini. Do you think that Gemini currently is accessible for all, digitally accessible for all, especially when it is integrated into education? Can everyone use it, like students with learning difficulties? Can they use it? Can they benefit of using it in their learning journey or not? And how to enhance accessibility in generative AI in general? Thank you.
شكرا. دكتور كثير خريجي، تفضل مهندس.
Okay. Let's start with the first question related to image and the Arabic script. As I mentioned in my slides, how the LLM works, it is a token in, a token out. When you are generating an image, you are generating pixels. The model doesn't understand the text in the pixel. Accordingly, it's generated according to probabilities that give a sense that it is a text, but it's really generating an image. There's more to that, I do agree. That's one of the limitations of those models. But that tells you also that we need to get to a level where maybe we generate the image independently and then we generate the text and we map it to the image, and that's a work in progress and not done currently, but it could be, it's a possibility. Okay. Did I answer your question? Okay, shukran. Dr. Gomez, thank you so much. It's a privilege for you to see you here. You are indeed popular. أنا أعتقد الأنسين كانت في مركزية. يعني تستاذ مراشي كمان. He was my professor here. I'm proud to see him here as well. So it's really great to see all of you. How to use LLM in education. So I am aware of the US market. In the US market, it is accessible today. I mean, let's say, make it practical. VPN to the US, there is a site that I'm happy to provide reference to one of the link where you find how to leverage that for education. Going from using specific content, quiz, things like that. What I showed what we call smarter learning smarter Gemini, it is available in the US, and we want to take one market at a time. So, did I answer the question or still? Okay, we can follow up on that because also Gemini is available. And again, officially it is released in the US, it is released in few markets. It is not released yet, let's say, officially. It works for Arabic, but it's not released yet for Arabic officially. The reason for that, there is more fine-tuning that needs to happen, and eventually, in a few months, that's the plan. But I do have a few tools. I'm happy to share them with you. Way how to operate them with everybody. If there is a way to communicate that, happy to do that.
We will make it available at our website.
Yeah. And actually there is tools today that you can upload your document or a PDF and interact with them and learn with them, do quiz, question answer. It is really available. So yeah, I think maybe
Digital accessibility.
Digital accessibility.
Accessibility. I think digital accessibility is getting to the application domain, I would assume, more than the technology itself. So if accessibility, so there's two things. In whether that's ChatGPT or Gemini, and again, saying, at least I'm aware of the US market, few market where depends on the size of the model. We talked about the size. There is the version that is free. There's another one where you pay a certain fee for it. And the difference, you pay a fee to get a bigger model because it consumes more electricity. The kind of a business model. If you are an enterprise, there is also the service of the cloud that they offer you to whatever model you have, and then you have accessibility to that. Maybe I think your question is different. How can we have free access to those kind of tools? And I think there is a lot of tools of that. I'm happy to share again. There is more than 8 or 9 LLMs, including those coming from Meta, that are very, very large, very capable. They could be fine-tuned, and they are not shy relative to the order of ChatGPT or Gemini. But there is another aspect that is very important I think we need to consider, which is the localization. Again, as I mentioned, these models are trained on general data, where I see the opportunities to adapt them to the local environment. I would love to see a big university or a big institution fine-tuning this model and say, this is for education, for this country, for these domains, and then you avoid hallucination and you have really the model addressing specific use cases. That's where it works best.